Good morning, student. Today we are going to discuss simple harmonic motion. So this is a topic for the class 11th physics and the unit name is oscillation. Okay, this topic belongs to oscillation units. First of all, we have to know what is simple harmonic motion. Okay, and then we will move into that show that the motion of the point, that is projection of particle performing uniform circular motion on any diameter. Okay, right? So first of all, simple harmonic motion. So simple harmonic motion, SHM, it is a to and fro motion of a particle along a straight line. Okay, along a straight line about a fixed point. It is called as simple harmonic motion. It's said to be simple harmonic motion. That means, suppose we take one particle here. These particles moves in the straight line. Okay, but motion only for this particle only to and fro. Okay, to and fro. So else, so to and fro. So this is a mid position or equilibrium position. So particle passing through that equilibrium position down here and passing through this position and upwards. So to and fro motion made by that particle. So this is called as simple harmonic motion. Okay. Again, I will say simple harmonic motion is a type of periodic motion. Periodic means repeated time. It is a periodic motion where restoring force acting on the object is directly proportional to its displacement. Because suppose object goes here, the force acting on that object and that force pulls that object towards the equilibrium position. Suppose object moves here, the restoring force acting on that object and pulls down here towards equilibrium position. So force acting on that object, which is directly proportional to displacement, but in opposite direction. Okay, which is directly proportional to the displacement, because displacement and force is in opposite direction. Suppose displacement here, force is here. Suppose displacement here, force is here, but in opposite direction, equal. Okay, directly proportional. Okay, so it acts in the opposite direction. Some key characteristics for that simple harmonic motion. There are three important points for that simple harmonic motion characteristics. First one, repetitive motion. Repetitive motion. That means the object moves back and forth repeatedly around a central point, that called as equilibrium position. Suppose this is the equilibrium position, the object moves back and forth repeatedly after a interval of time. Okay, so repetitive motion, it is a key characteristic for simple harmonic motion. And the second point, restoring force. Restoring force means, already I told you, a force which is always act on the object to bring back towards the equilibrium position. So force act and bring that object towards equilibrium position. Okay, right. And another one point, is it is a sinusoidal motion. That is displacement, velocity, acceleration of the object can be described as sinusoidal function. Okay, sinusoidal function means so object suppose one object around that circle. So we will draw one figure later. So object moves up and down. That is to and fro. So we will write the simple harmonic motion for that equations in the sinusoidal form. Okay, sinusoidal means up and like that waves come. This is a sinusoidal. I will show you one diagram. So here restoring force, which is directly proportional to for displacement. So we can write F is directly proportional to X. X means displacement. F means restoring force. So we can take out directly proportional to with one constant that is minus K. K is a restoring constant. Here minus means force is directly proportional to X and in opposite direction. So then only we can write it minus here. Okay. So K is a spring constant or force constant. Okay. F is a restoring force. X is a displacement from the equilibrium position. Okay. Right. So I will show you one file. So you can see one object in that circular motion. So you can see in that wave format, you can um, we need not we need not that sinusoidal wave, only circular motion here. Okay. So object black color dot, which is the object around that circular motion. Okay. So red color dot means a simple harmonic motion. That object traveling along the straight line only in the to and fro motion. Now you clear. Yes. So only black object, black color dot object around that circle, but in terms of red color dot, so which is moving up and down, that is to and fro along that straight line, passing through that equilibrium position. This is a simple harmonic motion because it has a repetitive motion and a restoring force F is acting on that object towards the equilibrium position. Yeah. So suppose red color ball moves up, there is an restoring force acting on that red color ball and pulls that red color dot towards the equilibrium position. Okay, right. So these are all for definition for that simple harmonic motion. Okay, right. So now we can go into that for the circular motion. Okay, suppose so first of all we will write that axis. Okay, so here is a x dash, here is a x, here y, here is a y dash. Here is the origin. Okay, object goes in the circular motion. So object I can take an as object as P in the position P. Okay. Suppose a particle P is moving along the circumference of the circle of radius A. So we can take an as A is a radius. Okay, A here radius of the circle. P be the particle moving along the circumference of the circle. Okay, this is clear. Okay, so then I can write draw one line from this line to this position. So here n, this is a distance y and this is theta. and this is theta. This is also theta. Okay. Right. Suppose a particle P is moving along the circumference of the circle of radius A. Let N be the projection of P. It is a projection because already I showed that suppose particles moves on like that. So red color dot moves on here. So that red color ball is a projection of that black color ball. Okay. So projection. N be the projection of P along that diameter y axis because so this is a circle and this is a diameter. Yeah, already you know that. Yes. So n be the projection of P on the diameter y axis. Okay, this is a x axis, this is a y axis, and x also diameter of the circle, and y also diameter of the circle. So, but the object here moves like in that circumference, and here n be the projection which is moves along that this line y axis. Okay, so this object moves like anti-clockwise direction. Okay, so omega. Omega means angular velocity because suppose one object rotating circular motion or anything rotational motion, we have to write angular velocity or angular acceleration. Okay, so here omega is the angular velocity. Omega is the angular velocity. Okay, suppose P complete one revolution. One revolution means P start here and goes like that and end here. So it completes one revolution. Then its projection point N makes one oscillation on the diameter because P goes here, and N goes here, and P here, N here, and P here, N here, P here, N here, and P here. So for the one revolution of that P point, the projection N makes a one oscillation on the diameter. In this diameter makes an one oscillation. For every one revolution of the P object, P particle, the projection makes an one oscillation on the diameter. It is clear? Okay, right. Then omega, already I told you, omega is the angular velocity. Then we have to introduce another one angular term, that is theta. Theta means angular displacement. Already I write in on the diagram like theta. Yes. So theta be the angular displacement of P at time t. Okay. Suppose one at the time t is equal to 5 seconds or 4 seconds or whatever else. So at that time theta be the angular displacement of the P. Okay. Right. Omega is the angular velocity. So what is the relation between theta and omega? So theta be the which is equal to omega and t because omega means angular velocity which is equal to displacement by time. So displacement equal to velocity time. So that only that's why I am writing theta is equal to omega into t. Okay, now you clear, right? So then in the circle, in the circle, this is O, this is P, this is projection. So OPN, this is one triangle. Yeah, correct. So triangle OPN. Take an triangle OPN. In that OPN triangle, first of all, find that sine theta. Okay. Find the sine theta. Here is theta. Yes. Here is theta. What is the sine theta for that triangle? Because already we know that sine theta, which is equal to sine theta means opposite side by hypotenuse. Yes, opposite side by hypotenuse. What is the opposite direction for this angle theta? Theta is here, opposite is ON. What is hypotenuse here? OP. Yes, clear? So sine theta opposite by hypotenuse. So sine theta here. So opposite side ON. Hypotenuse OP. Already we know that some other quantity, that is the distance between N and O is small y. Yeah, already we know that the distance between projection and the origin point. Oh, and already another one term, that is radius. Yes, for the circular of radius A. Yeah. So A is the radius. So A is the value of the hypotenuse. So ON, which is equal to Y, and OP, which is equal to A. Clear? Okay. Then we can take out A into here. So Y is equal to A sine theta. Y means distance. The object distance from the origin point, which is equal to A into sine theta. A means radius, sine function, theta means the theta value, angular displacement value. Okay, right. So this is a displacement. This is a displacement. We can replace theta by omega dt because already we know that theta is equal to omega dt. So we can replace theta by omega into t. It is clear. So now we have a displacement for this circular motion in the simple harmonic motion. Okay, right. So then we have to find velocity and then acceleration. Okay. So velocity, second one is velocity. Already we know that velocity is nothing but it is a rate of change of displacement. Yes, rate of change of displacement. Okay. What is mean by rates? With respect to time. Everybody changes with respect to time. So rate. Okay. So rate of change of displacement, which is nothing but V is equal to d by dt. So displacement here we can denote it as y. Yeah, we can taken as displacement as y. So we have to put y here. We don't put x or something s h. Don't do that because already we have a displacement as y, labeled as y. So we should put y here because of displacement. So rate of displacement means with respect to time. We have a y. So we can put what is y? A sine omega t. Correct? A sine omega t. So A is the radius. Radius is the constant term here because for the circle, radius does not change every second. Yeah. So radius constant, we can take a notes constant here. So A d by dt into sine omega t. So we have to differentiate sine omega t. Okay, we have to differentiate sine omega t. So how to differentiate? Suppose differentiate sine means it becomes as cos theta. So a cos sine, differentiation of sine cos. Yeah. So a becomes as cos and omega t. And also, again, we have to differentiate this quantity only. First of all, we have to differentiate sine theta and then this quantity. So sine becomes cos. So sine omega t, cos omega t, and then differentiate omega into t. So omega into t, that means like d by d into omega t. So d by d, so omega taken out here. So t only here. So d by dt. So dt by dt is 1. So omega is only there. Yes. So omega is taken out here. Okay. So velocity is displacement, rate of change of displacement, dy by dt. Y means a sine omega t. So we have to differentiate that quantity a sine omega t. So taken a is a radius, which is constant time, taken out before that constant differentiated time, and we have to differentiate sine omega t. So sine omega t becomes as cos omega t, and omega t becomes as omega. So we can taken as omega here. Clear? So this is velocity. And then we will move into the acceleration, because for acceleration, we need a velocity term or displacement term. Without the displacement term or velocity term, we cannot find that acceleration. Okay, so then only that's why we found that at velocity and displacement here. Okay, so next one, acceleration. Acceleration is nothing but it is a rate of change of velocity. Yes, correct. Rate of change of velocity. So, rate of change of velocity means it is differentiated with respect to time. Yes, correct. So, A is equal to differentiation with respect to time of velocity V. Here, already we have a velocity term. What is the value of velocity? A omega cos omega t. Yeah, you can check that. A omega cos omega t. Correct. This is the velocity. So we have to differentiate that velocity term with respect to time. So then only we will get that acceleration. Clear? Okay. So here a omega is the constant term. Okay. We can take a note a omega as constant. So a omega here. So d by dt cos omega t. Differentiation of cos omega t. So suppose cos we can take as a differentiation with respect to time. Cos becomes minus sine theta. So cos theta becomes minus sine theta. Okay. So cos becomes minus sine. Minus sine. And as well as omega t. And then omega t becomes as single omega. So we can put omega here. Yes. So cos omega t only becomes minus omega sine omega t, because differentiation of cos becomes minus sine. Cos omega t means minus sine omega t, and the differentiation of omega t becomes only omega. Already we know that. Okay. So this is a differentiation term for that this quantity cos omega t. So now we can multiply this quantity because a omega minus omega sine omega. So this quantity become like that as relation a minus a omega omega sine omega t. Yes, minus a omega and omega square. So omega square sine omega t. Okay. So we can take it as omega square here and minus here a sine omega t because we can interchange that quantity in multiplication. Yes, 3 into 4 which is equal to 4 into 3. So a minus a into omega square which is also equal to minus omega square in the a. Okay. So a sine omega t. Already we know that what is the value of displacement? Y is equal to a sine omega t. Yeah. So we can replace a sine omega t by y because that quantity is displacement. So a sine omega t becomes y because already we have a displacement. So here also one term is there, that is a sine omega t. So we can replace as y. So now a is equal to minus omega square into y arrived. Okay, clear? So here omega is the angular velocity which is constant quantity because in circular motion object moves along the circumference of the circle with constant velocity. That object does not change velocity for every second. So omega is a constant. So which is constant. So then this equation becomes a is directly proportional to minus y. Okay. A is directly proportional to minus y. Because omega is constant, we can take it as a constant as directly proportional to. So A is omega directly proportional to y means A increases y increases. Suppose plus means. Suppose minus means A increases, y decreases. In reverse order, y increases, A decreases. Okay, because displacement is directly proportional to the force, but which is in opposite direction. Yeah, already I told you. So acceleration which is acting on the object, which is opposite direction to that displacement. Suppose object in here like moves here, acceleration towards here. Suppose object moves here, acceleration towards here, towards equilibrium direction. So always in the opposite direction. It is clear. Always act in the opposite direction. So this is already we know that a simple harmonic motion. Simple harmonic motion is the one periodic motion. So which is a repetitive motion. Okay, along the straight line where always that object moves on the to and fro motion. For uniform circular motion means the object moves along the circumference of the circle with constant speed. Okay, constant speed, that is also called as constant angular speed. This is clear? Okay. So A is equal to, A is directly proportional to minus Y. Already I told you F is directly proportional to X or minus X. So K, we can replace K minus Ks, which is a equation of simple harmonic motion. Yes. So here force, also force has a acceleration by Newton's second law. F is equal to ma. So A is directly proportional to X means displacement, here Y is displacement. So minus means opposite direction. So once A directly proportional to minus Y equation arrived, we can say that motion of that projection, that n on any diameter is simple harmonic motion because y is the displacement of that projection from the origin. Okay, y is the displacement of that projection from the origin. So here y means the distance between the origin to n. Okay. So a is directed to minus y defines the motion of the projection n on any diameter is simple harmonic motion. Is it clear? Okay. We can finish this topic today. We will discuss another one topic in later class, another class. Okay. Thank you. Jai Bharat, Jai Hind. Thank you.